Hello everyone, we're going to go through one of the electron configurations. They all work the same way, so I'm only going to do one. And then we'll talk about the last page of this little quiz. So we're starting with tellurium, which is one of the more complicated ones. So what we needed to do first was put the electrons in. If you look over here on the periodic table, tellurium has, it's hard to see because I've made it very small, but it's 52 valence electrons. So we'll put them in right over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Notice I went to 4s, then to 3d, and I'm going with electrons one at a time in each orbital. After each orbital has one in it, then we pair them. And 4p. At that point I have 36. That would be the same as krypton. That'll come up later. After 36, so 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. So there's all of our electrons. Notice that up here at the top, I had to go single, 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 and then start to pair. So I have two that are by themselves alone in those two orbitals. The full electron configuration then would be the things that we have over here. 1s2, 2s2, 2p6. I'm just going to read them from low to high and write them at the same time. So 1s2, oops. I'm going to have to leave that up there because I can't quit my ink program. So it'll be a little bit in the way. But 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Right now I'm up to 4p up here. And I'm going to go to then 5s, 4d, 5p. So come on down here. After 4p6, 5s2, 4d10, 5p4. There are only 4 up here in the 5p. Okay, the outer shell is just the highest energy levels. So we're going to go up here and change colors, and I'll underline the highest energy levels. Maybe we're going to change colors. Okay, so the highest energy levels were the 5th energy level right here. But it shows up twice. So the 5th energy level shows up as 5s and 5p. So the outer shell would be 5s2 and 5p4. So only the highest coefficient goes in the outer shell configuration. The noble gas configuration, you're looking at tellurium over here. And you're going to go up one and over to the far right to krypton. So you're going to put krypton down and put it in brackets. After those brackets now include everything that's in krypton, 36 valence electrons. So if I count these down here, 2, 4, 10, 12, 18, 20, 30, 36, all of the configuration that I have here can be represented by just putting a KR. Then that leaves everything else to add at the end, 5s2, 4d10, 5p4. And that's how you handle the first 4 questions on this test. Once again, the outer shell is just the highest coefficient. Now we're going to take a look at the back page. On the back page, we have the dot diagram for carbon. So you remember we've talked about the number of electrons in the outer shell. This column has 1. This column has 2 valence electrons. This one 3, that one 4, and so on. So if I look at carbons, it's hard to see again, but that's number 6. You can look at your periodic table. Carbon has 6 electrons. So if I actually wrote the configuration out, the configuration would be 1, pardon me just a second. Configuration will be 1s, 2, 2s, 2, and 2p with 2. Notice the outer shell are only the second energy level electrons, so there are 4 of them. Or you can just count the columns. 1, 2, so this column all has 1, that has 2, 3, 4, 5, 6, 7, 8. Now helium doesn't have 8. It should really be over here. All right, but everything else in this column has 8. So carbon has 4. And we would then say I guess the question doesn't ask us to draw the dot diagram, it just says how many dots. So the answer is 4. Now, the electron configuration of tellurium, how many electrons are in d sublevels? We did tellurium on the previous page, so you can go back and look at that. Or you can just do what I'm about to show you. Here's tellurium. If I'm going to get to tellurium, I go 1s, I go through the 1s, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s, then I have to go through 3d all the way over, then to 4p, then 5s2, and then 4d10, and then 5p4. That's the same configuration that we wrote earlier. We went through d electrons in the 3d sublevel here, and also in the 4d sublevel. So there are 20 total d electrons in tellurium. 10 from the 3d and 10 from the 4d. Next question deals with the dot diagram for silicon. Silicon has, as carbon did, only 4 valence electrons. So the 4 valence electrons are placed 2 in the s orbital and 2 in the p orbital. And once again, just writing the configuration, 1s2, 2s2, 2p6, 3s2, 3p2. That would be the configuration for silicon. 2 electrons here are these 2 electrons. And then the p electrons would be in 3 different orbitals. Excuse me, 2 different orbitals because there's only 2 electrons. So this one is that one, and this one is that one. So 4 dots, the s, and then the p's go around by themselves before they pair up. So you go single, single, and single, and then pair, pair, pair. So the last question wants to know how many electrons are in the pink room in the above dot diagram. So let me put that dot diagram back. We had silicon. Better pick a pen color. We'll go with green this time. So silicon. And remember there were the old electron configuration 1s2, 2s2, 2p6, 3s2, 3p2. The s sublevel had only 1 orbital with 2 electrons in it. The p sublevel has 3 orbitals but only 2 electrons in the orbitals. So we've got a total of 4 electrons. They were right here. All right, the pink room in the boarding house activity we did when we began this unit, the pink room was the p sublevel. So how many electrons are in the p sublevel? It's 2. And that's it.